Okay, you should have a couple of pieces of paper. And what are on these pieces of paper? Well, first of all, the oldest thing that you should have had was like a paper with like maybe your designs. Your design and dimensions. Okay, don't forget, you're supposed to have all your little dimensions and all kinds of stuff like that. All right?
The one that developed over time?
What?
The one that developed over time?
Yeah, that's good. So design and dimensions and all of the modifications, that sort of stuff. That's on like the oldest paper that I think we have.
Is this the one that should be stamped? Yeah.
Yes.
Stamped?
No, we don't.
I don't think I ever stamped anything.
That's
No,
like
that's
assignment
not-
to create one.
Sample procedures, that's all you
Oh yeah, I think I did.
It's not homework, but
I think I did stamp a design, right?
Stamped our-
Yeah, there you go. The first design. Yeah, sure. So that is stamped. Okay, very good. On the day of, I gave you the lab paper, right? And on that lab paper, I asked you to make a guess, and then I asked you to measure, right? How much you thought it was going to shrink, how much you thought it was going to squish. Then from that, on this paper, you could then go ahead and do calculations. Those calculations should work out, essentially, PEG is equal the work, the non-conservative work that was done. If I do that up here, we get MGH is equal to the force of the egg catcher times, or the squish, right? How much it squished. So you're trying to estimate how much it squished. Now, some issues. H 1.15 meters plus or minus meters. And N, what was the mass of the egg?
63.9.
So then we'll say 60,
33.
but then it went up to what? And it went down to?
It was plus or minus 3.
Okay, so let's say, you know what? I already said last period, so let's just say 63 plus or minus 3 grams. Yes, technically I should have rounded it to 64, but whatever. Yes?
It's actually our procedure that was stamped, and then our designs how we developed it.
Well, he said to do it on the same thing.
No, you did it.
Oh, so you did it. Just kidding.
Okay, no problem. Everybody's good? Okay, so these pieces of information are going to be for your calculations, which will allow you to get an uncertainty on your final force. Does that make sense?
So,
Yes.
So the distance is estimated, it's not actual.
Because the reason is people didn't measure exactly some people didn't measure how tall their thing was. So I'm just saying it was 115 centimeters above the floor. Boom, that's how tall it was. And then what I'm saying is if you don't know the H, if you actually know the H, then you could do it plus or minus like 1 centimeter or something. So if your measurements were more accurate than this, do you understand what I'm saying? Like, let's say, for example, you say, no, mine was 8 centimeters tall, period. So then you would know that the height is like 1.07 to the top of your catcher. Do you get what I'm saying?
Yes.
Yeah, and then you do plus or minus a couple centimeters for the measurements. Then on the front, so what is supposed to be here, this is kind of like your design process. So tell me about your design, why you made it that way. Give me a little bit of prose about your design. Then you're going to do your force and uncertainty calculation on the front here, and then you're going to do your qualitative analysis. So that's what's going to be on the front page. Oh yeah, here, this is typed. Everything else is just handwritten. Like always, your top page should be typed. Second semester, we're moving away from these like little activities and moving more towards full-on lab reports.
These are little.
Yeah. I remember at UCLA,